Yesterday, October 20th, 2025, 3:11 a.m. Eastern Time. AWS East-1 goes dark. Not a minor hiccup, not a service degradation. Complete failure of the DNS system for DynamoDB in Northern Virginia. By 7:50 a.m., over 50,000 simultaneous user reports on Down Detector. Snapchat, down. Fortnite, kicked players mid-game. Coinbase, locked out during trading hours. Ring doorbells, can't see who's at your door. Even Amazon's own retail site went offline. 15 hours and 12 minutes from initial detection to full recovery. Hundreds of billions in losses. Over 1,000 businesses disrupted. And here's the kicker. If you're running everything in that one region, all those observability dashboards you built, they went down too. This is Faith, Freedom, and Tech. I'm Scott Oaken, and today we're talking about observability and why yesterday proved that most organizations are doing it completely wrong. Welcome back for those just joining us. I'm Scott Oaken, been in tech over 20 years, started programming at 11, worked across AWS, Azure, and GCP, building systems at enterprise scale. And yesterday was a masterclass in why observability matters. But first, I'm going to apologize. This is the second week in a row. This episode is late. Last week it was migraine, disabled veteran. It is what it is. Some days you hit harder than others. I just got to power through it when I can. This week, though, here's the ironic part. The AI editing and recording software that I use, it had a partial outage because of this AWS failure. So the very thing I'm talking about in this episode literally prevented me from getting this episode out on time. Look, I'm working on being more consistent with the schedule. We launched this show on September 22nd, just a month ago, and we're 9 episodes in. That's actually pretty good for a new podcast. But I know you expect consistency. Typically, we do a tech deep dive on Tuesdays and a Faith and Freedom episode on Thursdays. We missed our Faith and Freedom last week, but we'll have one this week. And as we grow, we're adding more. You'll start seeing Founders Fridays, Warrior Wednesdays, bi-monthly Small Business Saturdays, bi-weekly Tech Bites, and our special from the Free State episodes. Plus, I'm getting better about publishing the supporting articles on Medium and over at DevSecOpsWithScott.com. As we gain more listeners, I'm building in more buffer time, pre-record when I can, make this more professional. But right now, I'm figuring out the production workflow, running my consulting practice, dealing with health stuff, life. So bear with me. We'll get there. The content is worth the wait. Now, if you've been following this series, we've covered DevSecOps principles, Kubernetes orchestration, multi-cloud design in episode 6, and last week, platform engineering. All of that builds to what we're talking about today, because observability is how you actually know if any of that stuff is working. And yesterday, AWS reminded us why you can't just trust that things work. You need to see them working, or in this case, see them failing. So let me tell you what actually happened. Then we'll talk about what you can learn from it, including how to avoid being dependent on a single cloud provider for your entire workflow. Something I clearly need to implement myself. Let's get into it. So here's the timeline. These are the facts straight from AWS's official statement and the reports filed. 11:49 p.m. Pacific Time, October 19th. AWS begins experiencing increased error rates in US-EAST-1. That's their Northern Virginia region, oldest, largest, most critical data center for 12:11 a.m. Pacific, October 20th. AWS publicly reports issues, 22 minutes to acknowledge. 12:26 a.m. Pacific, root cause identified, DNS resolution failures for DynamoDB endpoint. So think about what DNS does. It's the internet's phone book, right? When DNS can't find DynamoDB's location, Applications lose their ability to access the foundational database service. And here's where it cascades. DynamoDB unavailable means the EC2 instance launch subsystem can't provision new virtual machines. Network load balancer health checks start failing. Lambda, CloudWatch, 70 plus AWS services start experiencing issues. 2:24 a.m. Pacific. AWS says they've mitigated the underlying DNS issues. 2 hours and 35 minutes from initial detection, but the damage is done. 8:43 a.m. Pacific. They identified a secondary issue. Underlying internal subsystem responsible for monitoring the health of our network load balancers. So not only did DNS fail, but their monitoring system for network health also had problems. Let that sink in. 3:01 p.m. Pacific. All services returned to normal. 5 hours and 12 minutes total. Now, here's what's interesting about US East-1. It's AWS's oldest region, launched in 2006. It houses 663 data centers. It serves as the default deployment region for countless organizations. When it fails, as cloud analyst Doug Matterdy said, we have this incredible concentration of IT services that are hosted out of one region by one cloud provider for the world. And that presents a fragility for modern society and modern economy. And this isn't the first time US East-1 has been at the center of major incidents. 2015, 2017, 2020, 2021, 2023, 2024, and now 2025. It's AWS's Achilles heel. Every 12 to 18 months, something major happens in this region. So let's talk about impact, because this wasn't just tech bros complaining on Twitter. Financial services. Coinbase locked users out during active trading. Robinhood had trading disruptions during market hours. Venmo couldn't process transactions. UK banks, Lloyds, Halifax, Bank of Scotland experienced login failures. Consumer services, Snapchat, over 22,000 peak reports. Reddit, 15 hours of Fortnite and Roblox, kicked players mid-game. Signal, the encrypted messaging app, completely offline. Elon Musk said, I don't trust Signal anymore because AWS is in the loop and can take out Signal at any time. And here's what really got me. Smart home devices. There was a Reddit post from someone saying, my bed is stuck in relax mode and won't change because their 8 Sleep Smart Mattress, a $200 per month service, became completely useless. Ring doorbell customers lost all security monitoring. A disabled person in Fort Lauderdale wrote to CNN, I use Alexa-enabled smart plugs to control the lamps in my room. I am unable to walk without leaning on crutches, so being able to turn lights and music on with my voice is very helpful. During the outage, my smart plugs became unresponsive. That's the human cost of cloud dependency. United Airlines customers couldn't access reservations. Canvas, used by 50% of North American college students. Students couldn't submit assignments. McDonald's and Starbucks apps, offline. Even Amazon's own operations. Warehouse workers and delivery drivers had internal systems go offline, forcing employees to stand by in break rooms and loading areas. Financial impact? The CEO of the monitoring firm, Catchpoint, estimates the financial impact of this outage will easily reach into the hundreds of billions due to loss in productivity for millions of workers who cannot do their job. Plus, business operations that are stopped or delayed. All right. So what is observability? Because I hear this term thrown around constantly, usually by people who think it just means more dashboards. Observability is your ability to understand the internal state of your system by examining its external outputs. It's not just monitoring. Monitoring tells you that something is wrong. Observability tells you why it's wrong. There are three pillars: metrics, logs, and traces. Metrics are the numbers: CPU usage, memory consumption, request rates, error rates, latency. These give you trends over time. They're what goes into your Prometheus, your CloudWatch, your Azure Monitor. Logs are the structured records of what happens. Every event, every transaction, every error, aggregated and searchable. This is your Elk Stack, your Splunk, your centralized logging solution. Traces follow requests through your entire system. When a user clicks a button, that request might touch 15 microseconds. Distributed tracing with OpenTelemetry or Yager shows you the entire path and where the bottleneck is. But here's what the AWS outage exposed. Most organizations had all of their observability infrastructure in the region that failed. CloudWatch, that's an AWS service. It went down during the outage. Your dashboard showing the health of your systems, they disappeared right when you needed them the most. Organizations that survived yesterday with visibility had one thing in common: observability platforms that were not dependent on AWS infrastructure. New Relic, Dynatrace, hosted independently. They kept working while AWS was burning. That's why I mean by uncorrelated monitoring. Your monitoring system can't depend on the same infrastructure you're monitoring. That's like having your fire alarm powered by the same circuit as the thing that's on fire. So what do we learn from this? Let me break down the actual lessons here. Lesson 1. Multi-region is the new menu. US East-1 failed across all availability zones. If your entire infrastructure was in that region, you were down, period. Multi-AZ didn't save you. You need multi-region. We talk about this in episode 6, multi-cloud. Active passive or active configurations with automated DNS fail Route 53, Cloudflare, and S1. When one region fails, traffic automatically routes to another. The organizations that stayed online during yesterday's outage, they had this already implemented. Everyone else learning the hard way. Lesson 2, observability must be independent. Your monitoring can't live in the same place as your workloads. Third-party observability platforms aren't nice to have anymore. They're survival tools. New Relic's 2025 observability forecast showed that high-impact outages cost enterprise a median $2 million per hour. But organizations with full-stack observability experienced only $1 million per hour, a 50% reduction through proper monitoring. That's not just dashboards. That's metric aggregation from multiple log collecting that works when your primary cloud is down, and distributed tracing that shows you exactly where the failure is. Lesson 3, disaster recovery plans that are useless if untested. How many organizations had DR plans that said failover to Azure, but had never actually tested the failover? A lot of them. And yesterday, when they tried to execute, they found their DR plans didn't work. Blue Mantis, a cloud consultancy, recommends monthly DR drills, not yearly, not quarterly, monthly. You run the drill, you find the gaps, you fix them. Because when the real disaster hits at 3 a.m., muscle memory kicks in. Lesson 4, dependency mapping is critical. Most organizations have no idea how many of their systems depended on DynamoDB until DynamoDB went down. Then they found out the hard way. You need to map your dependencies. Every service, every API call, every data flow. When one thing fails, what else fails? This is what tools like Service Mesh gives you. Visibility into service-to-service communications. Lesson 5. The control plane matters. AWS's own support ticket system went offline. Their health dashboards had delays posting updates. When your control plane failed, blind. This is why Kubernetes patterns matter. This is why, when we talked about platform engineering last week, you need a control plane that's resilient, that's distributed, that doesn't have single points of failure. All right, practical implementation. What do you do to actually implement this information? Step 1, assess your current state. Map every dependency in your infrastructure. What services are you using? What region do they live in? If that region fails, what breaks? Most organizations don't know the answer to this until they're in the middle of an outage. Do the work. Step 2, implement multi-cloud observability. Pick a third-party observability platform. Datadog, New Relic, Dynatrace. They all work across AWS, Azure, and GCP. Configure them to collect metrics, logs, and traces from all your infrastructure. Your dashboard should show you the health of your entire system, regardless of which cloud is having issues. Step 3, set up proper alerting. Not just services down alerts. You need that catch degradation before it becomes failure. Error rates trending up, alerts. Error rates trending up, alert. Latency increasing, alert. Database connections approaching limits, alert. And for the love of God, don't send all the alerts to the same Slack channel that gets ignored. Critical alerts need to page people immediately. Step 4, create response playbooks. When US-EAST-1 goes down, what do? Not theoretically, specifically. Who do you call? What commands do you run? How do you fail over to another region? Document it, test it, update it when things change. Step 5, practice chaos engineering. Netflix Chaos Monkey approach works. Deliberately break things to see how your system responds. Shut down service, simulate region failures. Kill pods at random. The organizations that handled yesterday's outage well, they've been practicing failure for months. When the real thing happened, they knew exactly what to do. So let's bring this back to faith for a minute, because there's a principle here that matters. Proverbs chapter 27, verse 12 says, "The prudent see danger and take refuge, but the simple keep going and pay the penalty." Yesterday, the simple organizations kept all their infrastructure in US-EAST-1 because it was easy, because it was default, because AWS never fails. The prudent organizations had multi-region setups, multi-region architectures, independent observability, tested disaster recovery plans. They saw the danger coming. Not yesterday specifically, but the possibility of regional failure, and they prepared. That's not paranoia, that's stewardship. You're responsible for the systems your company depends on, the data your customers trust you with, the services people rely on. From Ecclesiastes chapter 11, verse 2, give a portion to 7, or even to 8. You know not what disaster may happen on earth. That's diversification. Don't put all your eggs in one cloud, one region, one monitoring system. And here's the thing, the organizations that were prepared, they didn't just survive, they gained competitive advantage. While their competitors were offline, losing millions per hour, they were still operating, still serving customers, still making money. That's what excellence looks like. That's what proper stewardship enables. So where do we go from here? Next Tuesday, episode 11, we're diving into CI/CD, pipeline security, how you secure your software, supply chain, SBOM, artifact signing, secret, building on everything we've covered. This Thursday, we'll have our Faith and Freedom episode covering what's happening last week and this week, but we'll see what happens. But this week, your action items. 1, audit your observability stack. Is it dependent on the infrastructure you're monitoring? If yes, fix it. 2, map your cloud dependencies. What regions are you in? What happens if they fail? 3, test your disaster recovery plan. Actually test it. This week, find out what's broken before you need it in production. 4, set up proper alerting, not just down alerts, degradation alerts that give you time to respond. 5, read the AWS post-event summary when they publish it. Learn from their failures. It's free education. And if you're finding value in these episodes, share them. We're a month in, 9 episodes deep. We're building something here. Check out the articles on Medium at scottwhoughton.medium.com or over at DevSecOpsWithScott.com for deeper dives into these topics. This is Scott Houghton reminding you that observability isn't about having pretty dashboards. It's about surviving the next outage, because there will be a next outage. Keep building, keep monitoring, and test your assumptions before reality does. Until next time, God bless. I hope you enjoyed this episode of Faith, Freedom, and Tech. If you did enjoy this episode, or if it helped you, like, subscribe, and leave a review. It helps others find us. Share this episode with someone who needs it. We're building a movement here. Find me on X at FaithFT_podcast or wherever else at Faith Freedom Tech. Check out faithfreedomtech.com for show notes and more. Keep building, keep believing, and God bless.